Now I am going to present topics from Unit 3 of Parallel Algorithms. The topic includes 2D MES, SIMD model, parallel algorithms for reductions, prefix computation, selection, odd even merge sorting, and then matrix multiplication. First, let us discuss the first topic 2D MES SIMD. Here, SIMD it stands for single instruction and multiple data streams, which is nothing but this machine receives instructions from the control unit, a single instruction from the control unit, and it works on multiple data that can be represented as a machine that includes many processing units under the supervision of a common control unit in such a manner that all the processor receives the same instructions from the control unit, but it operates on a different items of data, so that each processor can store both the program and data in its own local memory, which is nothing but a processor has its own identical copy of the same program in its local memory. In addition to the local memory, a processor can share data from the other processor, so which can be carried out in this SIMD model by means of an interconnection network or through a shared memory. Right, next, what is a mesh network? A topology where a set of nodes form a p-dimensional grid is called a mesh topology. All the edges are parallel to the grid axis and all the adjacent nodes can communicate among themselves. That is the meaning of this mesh network. Every processor can communicate with other nearby processor. So we can calculate the total number of nodes in a mesh network in such a way that number of nodes in a row into number of nodes in a column. We can resemble this SIMD model as a graph in which all the processor represents the nodes of a graph and the edges represents the links of the graph. So it can be seen as the nodes of the graph are the processor and the edges are the links between the processor. Since each processor solves a small part of the overall problem, it is necessary that a processor should communicate with each other while solving the overall problem. That is a solution we can obtain by means of a SIMD mesh network. So this can be represented by a means of a diagram. In this diagram, there are 9 processors. It is arranged in a 3-dimensional rows and columns, that is P0, P1, P2, P3, P4, P5, P6, P7, P8. In such a manner that P0 can communicate with the P1 and P0 can communicate with the P2 and P0 can communicate with the P2 and P0 can communicate with P4, that is P6. These networks can be evaluated by means of 3 parameters. One is a diameter, the second one is a bijection width, and third one is a scalability. Let us discuss what is a diameter. In a mesh network, the diameter is nothing but a longest distance between the two nodes in its diameter. We can define this such that a p-dimensional mesh network having kp nodes has a diameter of p into k minus 1. A network with the diameter can be calculated by using the formula p into k minus 1 in such a way that p is nothing but a number of processor and then k is a longest diameter. Next one is a bijection width. A bijection width, it is a minimum number of edges needed to be removed from a network to divide the mesh network into two halves. Suppose if we want to divide the network into two halves, we must know how many number of edges to be removed, so that we can say that which is nothing but a minimum number of edges that is to be removed to be called as a bijection width. Dividing the network into two halves, by means of a by removing the number of edges, which should be a minimum. That is called a bijection width. And then last one is a scalability. A network model must be scalable in such a way that it can easily add the processor and it can easily remove the processor, so that without affecting the already available networks and resources, the network should be able to solve the given problem. That is nothing but a scalability. Adding the resources, adding the processor or removing the processor, the network should be able to cooperate under the available resources. That is the meaning of scalability. So which can be given in this diagram as a maximum node degree. Here is D equal to 4. That is for a network, for a processor, how many number of edges it can communicate to the nearby processor. Therefore, for every processor, there is a degree node is said to be a 4. Say for example, P0 can communicate with the P1, P0 can communicate with the P3, and P0 can communicate with the P2. Okay, therefore it's said to be a, and P0 can be communicated with the P6. Totally P3, P1, P2 and P6. 4 nodes. Therefore maximum node degree here is 4. And then network diameter, just now we have learned what is the network diameter. It is the longest distance, which is nothing but a root P. So P is nothing but a number of processor. Bijection width is number of edges which is to be removed and which is to be minimum for a network to be in a stable. That is dividing the networks into two halves. How many number of edges to be removed, which should be a minimum. That is said to be a bijection width. So which is nothing but a 2 root P. Here it is said to be a root 2P. So therefore maximum node degree D equal to 4, network diameter equal to root P, and bijection width equal to 2 root P. Okay, so that's all about this 2D mesh network.